Hello again. In this video I'm going over the black box penetration test number 2 on the INE platform, and it says that in this lab environment the user is going to get access to a Kali GUI instance. A web server can be accessed using the tools installed on Kali on this website. However, there is another machine in the setup which is not accessible from the Kali machine but is accessible from the web server. So compromise both machines to retrieve the flags, and these are the tools that they suggest using. Okay, so let's get started. I already did a video, like a full video of this lab, and then I realized the music was too loud and it was kind of suffocating my voice, so I realized to do it again. Okay, so let's just get started. Just gonna create some notes. Okay, so we are able to reach this website, and we see that the time to live is 64. This means that that we are dealing with a Linux machine. This is a Linux machine that is responding to us, because Linux by default sets its time to live to 64, and usually when you are pinging a machine that is not on the same network as you will get 63 or 62. The fact that we get 64 means that we are on the same network as this web server. Let's check our IP address. So this is the IP address of the web server, and this is our IP address, which confirms that we are on the same network. Okay, so let's start enumerating this. Let's just do a basic nmap scan, and immediately we get 3 ports that are open. Okay, so let's do some service enumeration on these ports. Check SV on this IP address, and in the same time let's check port 80 to see what's going on. We get the default Apache page. Nothing useful. Let's go back here. Okay, and nmap is done. So, okay. So port 80 is Apache, we already saw that. Port 5000 is a service that nmap did not recognize, and 8000 is a service that nmap did recognize, and it seems to be a Python based web server, which is worksuck, and it's usually based on Flask if I'm not mistaken. let's check the response that nmap did not recognize, and we see content type. This is most likely a web server. This is an API response. But let's move on. Let's manually check these ports. 5000, and we get an online calculator. Invalid expression, so it's only taking numbers. Okay. Nothing interesting in the page source again. Let's check 8000. Nothing again. This looks like a JSON format error code. So I'm guessing it is an API that we are dealing with. Okay. So let's do some directory brute forcing. Let's start. Okay, so nothing interesting. I mean, we get 403s. So let's check 5000. The response code 403 means that permission was denied to access these. So they exist, but we do not have permission to access them. And on port 5000, we don't get anything interesting either. Let's check port 8000. And on port 8000, we do get interesting responses. We first have console and an exposed Git directory. So let's check the console. That would explain why we get this error message. Yeah, so it is a console where you can execute Python expressions, but it is locked by a pin. Just doing random numbers. Okay, so brute forcing this seems kinda useless, but John Hammond did a video lately on ways you can actually find the correct pin. I'm not sure if we want to do this now. It's kind of not the purpose of this lab environment. It's not supposed to teach you that, but it could be good to keep that in mind. Let's actually check if there's anything else on the Git directory, and let's manually check this. So we get a file to download. Let's save this file. And we get index and config. Config looks interesting. And we get some credentials out of that Git directory. Let's take them in the notes. And let's check this. Seems to be referencing something. Okay. Let's check this response. And it's referencing a remote origin URL. Okay. Let's try to clone this repository. So git clone this. Counting objects, compression objects, and packing objects. Done. Okay, let's ls cd into that newly created directory ls api.py. Let's nano that. And it's Flask. It's importing the Flask library and workcirc library routing. App Flask name, which is a typical way to start a Flask web server. Creating some classes, pretty usual stuff. And we have a interesting function here, is valid, and it takes the parameter expression. Allowed characters are these. So, and we're doing a for loop, so for I in expression, if I is not in these allowed characters, then it's gonna return false. If I is in the allowed characters, then it's gonna return true. Okay. Request method does not equal post, then it's gonna return unsupported method. This is usual stuff, and we've got JSON as well, which explains that error message on port 8000. Just doing some checking, and if not is valid expression. So if the expression is not valid, then it's gonna return in invalid expression, which we saw firsthand when we were manually enumerating that online calculator. And if name equals main, meaning if this file is run locally, then it's gonna run the online calculator. Okay, that's good. So what we want to do is make some changes to that Python file, but before we do that, let's check the logs. It's not a git command, maybe it's git log. I forgot. Yeah. Minor formatting. We enabled regular expressions route for app resource loading, and to avoid arbitrary file read. Okay. Critical. Fixed an issue that leads to remote code execution. Eval is now protected. And eval is the Python function. Just a second, I need to change this music, I don't like it. Maybe this will do fine. So I was saying that eval is the Python function. Let me just show you here. Was it 5000? Yeah. So when we do, for example, 2 plus 2, that 2 plus 2 calculation is gonna get executed by the eval function, because eval is a function that just executes whatever you give it. And in this case, he fixed the issue by creating that new function that is called isValid, and that takes the parameter expression. So he fixed the issue by just validating that the user input is actually numbers or useful characters, at least for calculations. So what we can do is just comment out that new function, and we should be good. Now, for some reason, I do have some keyboard problems when I am in the lab environment. I'm not sure why. So before I do this, let me just copy this hashtag octatorp symbol and paste it here, and let's go back there to modify. Just gonna comment out everything, because why not? Did I delete something? No, I did not. And no. We want to comment out this one as well. Okay, let's save this and let's do git status to see if it was indeed modified. And it was modified api.py. So let's do git add everything in this directory and git commit. I think it's tag m to specify what was done, so we can do fixed code and then say that the author of these changes was Jeremy, because we have his credentials. So Jeremy and his email, which he so graciously just left for us. That looks right. Okay, so it does say that the file was changed. Let's push these changes to the remote repository, and it's asking us for a username, so Jeremy, and his password is diamonds. Okay, it looks like it worked. It says done everywhere, so let's curl the website to see if the changes were made. Was it 5,000 or 8,000? I don't remember. I think it was 8,000. .git and api.py. Okay. Okay, we can check this manually. Just wanted to see if it did actually work. Like if the code was commented out, but whatever. It's not very necessary. explain. Still said is invalid expression, but let me get a bash reverse shell. Just 1 second. Okay. So echo this. So let's change this. Let's use a different port. Let's use this one. And just gonna copy this pipe as well, because just like I mentioned earlier, I do have some problems with their lab environment. And let's pass that to base64 to encode it. And what happened here? And I'm gonna explain why we need to encode it. Okay. So in our reverse shell we have some characters like this one and others that can be incorrectly interpreted by the calculator, or actually correctly interpreted, but that would make our payload not work. So we're gonna encode it in base64, and then we're gonna have the web server decode it for us, if that makes sense. But not to worry, I will walk us through that. So let's start a listener on the same port, which was 1337. Delete port, and let's go back here, and we're gonna need to import the OS module. So because we're gonna need to execute code, so let's import os.system, and it's so slow for some reason. And let's say echo this, and we need to pipe this into base64 again. tag decode meaning, and then we need to pass this into bash, because bash is going to execute this code. Close the parenthesis and say I'm having some network connectivity issues for some reason. Okay. Okay, so it seems to be fixed now. I have a typo here. And I'm still not getting the call back. Maybe I'm doing a mistake. I think I am. Let me just check. So it seems like it did not work. Okay. Okay. So this is commented out. This function is commented out as well. But for some reason it still returns invalid expression, which it should not be, because the function is commented out. Something is wrong. it seems to have worked. Yeah, some little debugging was necessary, but yeah, so we did get a shell, as you can see, Python API, and we got a shell as the root user. Again, this lab is not meant to teach you privilege escalation. It's meant to teach you like how to get from one device, how to get to a device through enumeration and some quote-unquote code review and stuff like that. And then once you get to a network or a compromised machine, sorry, then you need to find another machine that is only accessible through the compromised machine. So let's see what's going on here. Alas, I remember that the flag, if I'm not mistaken, was in the temp directory. Yeah, you can cat the flag, but it's not going to be really useful. Let's check the network interfaces. Ifconfig, no. Okay, IPA. What's the IP address of this machine? 213. So used to the output of ifconfig. This looks so weird to me. And we do see that it has another network interface. This one, it's part of one. Okay, let's take these into the notes. That's good. Let's get a what's it called, Meterpreter payload, because we're gonna need to pivot, and in here you are not allowed to modify the IP routes in this lab environment. It gives you some Docker errors that you cannot modify the IP routes, even though you are the root user, but we're still in a Docker container. So yeah, so you do have to use Metasploit, unfortunately, and fortunately, both of them, because Metasploit is still it's still really useful, but I don't like using it a lot. It's to me it feels like a very lazy tool, but it's still gonna come in handy and gonna be useful to us in this lab environment. Let me just copy the payload, how to create it. So msfn payload meterpreter reverse TCP, and our lhost is gonna equal to this. Oh. And our L port is gonna equal to 8443. The file type is gonna be ELF, because it's gonna be a Linux executable and a Linux binary. So let's name the file rev.bin. Okay, let's see if we have wget. We do have wget, so we can start a Python web server, http.server. Okay, and it started, and we do have the payload on the same directory in which we are starting the Python web server, which is going to be useful when we are going to be wgetting this. So http and 192.2.3.2, and this looks very confusing. Rev dot bin to get a get request, and we get 100%, so the file did get downloaded. So let's see, and it's in the temp directory. Not that it matters that much, so let's file rev.bin to see if something happened when it was being transferred. And no, it's an executable. Let's ls.la to see if it's an executable. It's not an executable, so let's make it that way. Chmod plus x on rev.bin ls.la, and it is now an executable. Let's shut down, or at least try to, if the lab responds. Okay. Start Metasploit. Let's use exploit multi-handler to be able to catch the reverse shell exploit. Let's set our payload to Linux x64 Meterpreter TCP. Options to see what we need to change. Lhost, so set lhost to this. We need to set the same port that we specified when we were creating the reverse shell. It was 8443, and let's run it, the executable here, rev.bin. Let's run the exploit, and we do get a shell. So who am I? Info. Let's get a shell. Okay. Config is not here. Let's exit to see if I am able to do it from here. If I can type it, and we are able to get the network interfaces informations. Yeah, we did get this new network in the notes. Yeah, but it's just much better to look at this for me than to look at this. Just it feels like there's so much more information here for no reason. Okay, so let's background this session, and we need to pivot to the other network. In order to do that, we need to let's try, for example, let's try pinging this new network. As you can see, there is no ICMP replies that we are getting here. We are not getting any connectivity, which is just what they mentioned. They said that the first machine we will compromise will be connected to another network. So yeah, so we're gonna need to add a new route. So route add. I don't remember the syntax. Route. We just need to, I think, let me change this. Let me try it this way. On the first session that we backgrounded, so the route was added successfully. This just means that we are going to use the first machine that we compromised, that we backgrounded now, as a pivoting point. I hope that makes sense. And since we are not able to reach that network, we'll use a SOX proxy. Let's search for it. A proxy that will channel our communication with that network. Actually, let's just use 0. Let's exit from here, and let's see the options that we have to set. Server port. Let's set server port to 9050 because we're going to be using proxy chains, and the default port in which proxy chains operates by default is this one. And I'm just gonna change the version as well, even though I think both of them will work. But in this case, because I think when I did some research on this, the only difference is that the SOX 5 is more advanced and it supports UDP. But yeah, let's just use 4A because it worked for me when I did the lab before. Okay, did I miss something? Nope. Okay, so let's run this in the background. Starting the SOX proxy server. So let's now use proxy chains to forward our nmap scans. We will not be pinging because ping requires raw packets, and which is not possible through a proxy. That's why we can use this switch so that we do not ping. And let's do a TCP connect scan on this. Let's start with the 3. See what we get, and we immediately get this port 8080 that responds, and it is open. Okay, so right now we're gonna need to modify our browser so we can so it can use the same configuration as our proxy chain, and so that we can be able to access this this web server. So let's go to our preferences. I think it's in settings actually. Let's look for proxy, proxy settings, and we're gonna manually enter our informations. So manual, we used SOC version 4 if you remember, and the host is gonna be localhost, and the port is gonna be the port which is used by proxy chains, which is this one, and okay, that's good. What was the IP address again? Was this? Let's try to visit this. No, it was 8080. It wasn't HTTPS. And we do get a response, which is a Jenkins web service that is usually, which is actually used by developers. Okay, let's see what's going on here. Let's go to manage Jenkins. Okay. So from here, as a pen tester, as a penetration tester, the thing that should interest you, I mean, you can go to manage users and check if there's other users. If this was like a company network, but this is the other and last machine that we need to compromise on this network. So we need to go to script console, and it's gonna ask for a Groovy script that we gonna need to. I mean, in here it's just a default Jenkins, like it's not trying to tell us what to do. It's gonna execute whatever Groovy script we give it. So normally you would try to give it a reverse shell, but since in this case this web server is not going to be able to reach us back because it does not know how to do that, what we're going to do, since we are able to route our traffic through the compromised machine, we're going to use a bind shell instead of a reverse shell. A reverse shell is the compromised machine, or the compromised to be machine is going to call back to you, and the bind shell is just you connecting to that machine, if that makes sense. Unfortunately, I do not know Groovy, so I'm just gonna be, I do not know Groovy, I don't know anybody that does, but I'm just gonna copy one, a bind shell. Just give me a second. Okay, there we go. So this is the bind shell that we are going to be using. So let's run this bind shell. Let's go back to our terminal here and let's use proxy chains again with netcat on this IP address. And on which port was it? Quad 5s. Okay, who am I? And we are the user Jenkins, so we were able to compromise this machine as well. So let's ls, you can see the home class. This is basically what we need to do. We are not supposed to get root privileges on this Jenkins machine. That's basically this lab. I really enjoyed this lab. I'm gonna be honest, the first time I did it, I got stuck so many times and I did not know what I was doing. And I wanted to document this process so that I can always look back on it, and it's got a lot of useful information. This is what I like the most about INE, is that it's actually very realistic in my opinion. I think it is a shame that we cannot manually add routes on the lab environment, but it is okay because yeah, on the exam you can actually add routes manually, which is good. You're not forced to use Metasploit. It's not like Metasploit makes it harder or anything. It's actually the opposite. It makes it easier. But yeah, enough with all the chatter. I hope you did get something out of this video if you did watch it, and good luck. Thank you for watching. Take care. Bye.